Okay, I think we're going to go ahead and get started. So welcome everyone who's joining us virtually for our latest in a series of technical meetup discussions. Today, we're going to be talking about one of the best kept secrets here at DoorDash Drive. By way of introduction, my name is David Azose, and I lead engineering for the Drive team. I'm actually joining today's conversation from Seattle, where I also operate as the site lead for our DoorDash Seattle site. I'm very quickly going to kind of give an overview of the agenda for today, and then I will open with a bit of an introduction and then hand it off to the team. So I'll spend a moment kind of giving a high-level overview of what Drive is and sort of frame the conversation. We'll hear from Jay, who's going to talk about kind of a deep dive of how we built Drive from nothing into what has become a multi-billion-dollar business. We're then going to do a series of lightning talks, and we'll save time at the end for some Q&A. All right, so as I mentioned, I'm joining today's conversation from Seattle, where I also operate as the site lead for our DoorDash Seattle site. Seattle is actually home to a growing number of engineering teams here at DoorDash, including the Drive team, which has a pretty significant portion of its footprint up in the Northwest. And while today's session is going to focus largely on a technical deep dive of Drive, I'm more than happy to field questions about the Seattle site as well in the end. So if you do have questions pertaining to Seattle more broadly beyond just what we're doing on Drive, feel free to ask those during the Q&A session as well. We're actually growing quite a bit up here in Seattle. We have a variety of interesting roles open right now. You can learn more about those at DoorDash.engineering/Seattle. That's DoorDash.engineering/Seattle. And before we dive in, two last quick housekeeping items. The first is for the Q&A that we're going to do at the end, we're going to use the Zoom Q&A feature. So feel free to post questions there, and we will do our best to get through them. The second is we may share information in the Zoom chat throughout our discussion, so just keep an eye out for messages that are popping in there from the hosts as we go through the content in the presentation. Okay, so with that, let's move to the next slide and let's dive in. All right, so what exactly is Drive? So, simply put, you can think of Drive as offering delivery as a service powered by the DoorDash platform. So to best understand this, let's take a concrete example. Imagine for a moment that you are a restaurant and you want to provide delivery to your customers. Maybe you're a pizza joint, maybe you're a fast casual eatery, something like this. And while this sounds simple enough, and I'm sure you can think of certainly the pizza joints of the world that have offered this for quite a long time, it's actually a bit of a challenging problem without economies of scale. And so, the best way to talk about that is actually to look at these two pictures that I think sum up the problem and the solution quite eloquently. So let's start with the first picture on the left. What you can see here is that, while in an ideal world, it would be very easy to predict orders that come in throughout the day from your customers, and therefore, hire drivers to supply those orders in a manner which would be, sort of cost effective and high quality. In practice, that's not typically how it works, right? Like for a whole host of reasons, on any given day, you may have more orders than you have drivers to supply them, or you may have more drivers than you have orders needed to be fulfilled. And so typically what this results in is either a very cost ineffective solution where you're buffering the amount of drivers that you hire in your fleet to ensure that you can always deliver with quality to your customers. Or if you take more of a cost effective approach of trying to match the size of your fleet to the orders that you're predicting you're going to get, there will be moments throughout the day, throughout the week, where you simply don't have enough delivery drivers to meet a spike in demand, and the quality for your customers will take a hit. The pizza won't come in 20 minutes, it'll come in an hour. It's a poor experience all around, and obviously not ideal. And so what Drive aims to do is it aims to offer delivery at the unit of a single delivery, and really to use economies of scale to solve this problem for all merchants. And so in this new hypothetical world, the same merchant that wants to offer delivery to their customers can continue to do so, but they can do it powered by the DoorDash platform, where instead of hiring the fleet of drivers themselves, they can request as the deliveries come in that DoorDash send a driver to their restaurant, pick up the order, and bring it to their customer. And so this is really the hypothesis or the thesis behind Drive and sort of the why. You can think of Drive as serving the merchant as the primary customer, although of course, it is by proxy serving the merchant's customer as well. And so with that, I'm going to hand it over to Jay, who's going to talk a little bit about kind of growing the Drive business and expanding logistics reach with Drive. And then, as I mentioned, he'll hand it off to a series of other panelists we'll chat through some lightning talks on a variety of topics. All right, Jay, over to you.
Cool. Thanks so much, David, for the introduction. So my name is Jay Bhat. I lead our fulfillment engineering team here at DoorDash Drive, and I'm located out of the San Francisco Bay Area. Today, what I want to talk to you is a couple of things. I wanted to tell you folks a little bit more about our Drive platform and a little bit more depth than David went into, why we're doing this, how we did it, and mostly focus a lot of the time on how we were able to build that billion-dollar business in just under 5 years, and what were the steps and really interesting takeaways that allowed us to get there. So on the next slide here, this is kind of just a high-level overview of Drive. I want to start with our mission statement. Like, why are we doing Drive? What's the goal here? And the idea is we want to, as a company, not just for Drive, but the entire business, we want to become the most efficient and the most effective logistics platform to enable delivery of anything from anywhere. This is a key distinction, right? Like, DoorDash is a logistics company. What we're trying to do is be the best way to deliver goods, no matter what they might be and no matter who they might be for. So, a lot of folks have historically thought of DoorDash as a food company. It's what we're most well known for. But the way that we get really effective as a platform and really add more and more value to our users, whether they might be our merchants or the end customers or our dashers, it's really by driving as many network effects as we can across our different lines of business and our different products. So how did we do this? We built and scaled a platform that allows us to ingest a delivery request from any number of sources, whether it's a restaurant, a merchant, a business, or even an end customer at the end of the day, and be able to fulfill it at a reasonable price at a predetermined contractual obligation, and do it as efficiently and effectively as possible to allow ourselves to be profitable and allow our customers to see a lot of value to their business. So you might ask, why is this hard, right? What is the challenge of Drive? We might just be building on top of the marketplace, and that might seem straightforward. With Drive, we have a number of unique challenges that are really centered around the fact that this is a business-to-business product. We have a lot of expectations from our merchants, and we need to be able to capture that volume in as many different ways as possible. And once we do that, we want to give them as many offerings as we can, more than just going into a DoorDash application and ordering from a restaurant. How can we provide as many services and opportunities for them to grow their own businesses and to be able to grow as many different types of businesses as possible? We have the unique advantage on Drive as this logistics as a service product to really be focused on fulfillment quality, quality of how we're doing deliveries and optimizing the cost there, without having to focus too much on the consumer experience, which our merchants are mostly controlling. So it allows us in a lightweight way to agilely build these products, and we can get into some of that a little bit later. So I'd like to talk about some of the initial challenges that we had when we first got Drive off the ground. This was about 6 years ago now, give or take. And building a new product can be very challenging because the sky is the limit. You really want to dream big, but start small. And it can be very easy to try to get out the gate, to hit everything, build that perfect product that solves for all the use cases. What a lot of companies see is you burn through all your money this way, and you don't end up actually shipping anything or delivering anything. All of a sudden, you need to move on because the cash isn't there anymore. So what we did on Drive is we really focused on limiting the problem space and limiting the surface area of what we first tackled, allowing us to build a really high quality product at very low scale. So our first kind of investment here was with catering delivery. You can see on the right, this is our first web form that we use for ingesting our orders. And the idea here is any restaurant that had large order volume, call it they're trying to prepare for a wedding or a birthday party, and they had phone orders or customers walking into the store that wanted to get delivery and set up at that event, but these merchants weren't able to fulfill that. They didn't have the drivers, they didn't have enough drivers, they didn't have any drivers, or they didn't have the training to do these things. So how can they leverage our platform to do that? So what we did is we found our highest quality dashers with really good ratings and special training and even special equipment like these large catering bags to go ahead and fulfill these orders. So as I mentioned, this allowed us to build a high quality product, which, as you can imagine, had a little bit lower scale than if we were doing, all the food deliveries for, say, a Chipotle or a Subway or some other large merchants like that. So from there, the next milestone was really starting to achieve scale. So how can we expand out on this product that we build and really tell an integration story for how can we start capturing more and more volume and moving on into broader use cases. The next step was to figure out our path towards creating a public API or a way to ingest as much order volume as we can. This was also a very iterative process, right? In your early days, your team's a year old, you have a couple engineers. It's very easy to jump to an API spec, but when you're thinking about building a public API for merchants, you end up getting very locked into the decisions you make early. As many of you may know, building an API contract, that becomes a long-term contract, and breaking changes, non-backwards compatible changes to this API cause a lot of challenges, both for you and for your partners. So in order to curb that a little bit, we started by building to an external API that one of our partners that had a significant amount of volume had, since they worked with many delivery service providers. What that allowed us to do was build the fundamentals of our system. How can we think about order ingestment? How can we think about fulfillment? And how can we start to understand some of the scaling challenges that we're going to that we're going to run into either today or down the line, and inform the decisions that came to next what was our V1 public API. When we built that V1 public API, there was some considerations around how do we build it for the use case today, but how do we make sure it's future-proof enough that it's going to give us runway until the point where we actually do need to do that revision. And this API actually did last us for 4+ years, and now we're finally in the process of versioning it for some good reasons, which Patrick will hopefully get a chance to touch on a little bit later. And the third thing on the integration story is, yeah, public APIs are great, web forms are great, but there's all hosts of different types of merchants and partners that want to send us volume, and these might not match for everyone. So how can we really think creatively about some of the other ways that we can receive orders, whether it might be doing things like ingesting email orders that are coming in a specific format to help support some of these, what I might call like middle tech merchants, where they're not too high tech to build to our API, but they have more volume than they can really manually submit order per order. And then finally, the other thing that really helped to get us off the ground, and this may seem obvious in some ways, is really connecting with your audience. I think for us as engineers, we really understand finding product market fit and doing product market research is very important. We might do things like go on forums or look at blog posts and things like that to inform our product. But in the early days, at a startup in particular, wearing many hats is very important. By being more than just an engineer, by being an operator, by being involved in sales and business development conversations, you really get a very unique perspective on what does the market need, what are you trying to build. I've found too often in my past that by operating in a silo, kind of building what you think needs to be built early on and finding out too late that what you build isn't actually what people need, you can really fall into a hole and get behind there. So, our strategy here was to constantly iterate on those learning and make sure that what we built at the end of the day was what people needed. We were hearing their concerns, really hearing the hard feedback at many times and being able to account for that. So yeah, next I wanted to talk about from here, this is where we got kind of 0 to 1, we got off the ground, we got a footing. How do we really exponentiate our growth from there? So there's a few things that were really key to our strategy here. The most important one I wanted to talk about is how we created what we call a startup around Drive. So Drive operates within DoorDash as a fully contained business. So what I mean by that is on top of the obvious working group that many think about, which is engineering, product design, and data that work very closely together to to build a product. How can we create a broader and more steady state working group across the entire business to solve these problems? So, strategy and operations, as well as sales, finance, and support are a large part of our organization, just in terms of sheer number of people, but also in terms of impact to the business. And by looping these people in early, by understanding how we can work together, how we can leverage, and how we can learn from each other, we were able to make really good products, really great products that weren't always just strictly rooted in engineering solutions. So, part of what was important here was being able to take risks, being able to experiment quickly, and not only just in engineering fashion, right? So using operations, using the existing products that we have to get early learnings when we're trying to invest in new areas. The second thing is, and I touched on this a little bit earlier, not biting off more than we can chew. So it can be very easy to build, that golden product, that perfect thing that everyone wants, or build for a scale that you feel you might achieve in 5 or 10 years, where you're the biggest kid on the block, or whatever you want to call it. But that can be crippling in many ways, where by the time you're actually able to build that product and make those trade-offs, it's really too late. Someone's beaten you to the game, or you spent too much money. So thinking about a 1 to 2 year horizon, and this exact amount of time might vary based on use case, but building for 1 to 2 years in the future gives you a lot of runway to really take the learnings from what you built. And a year or two from now, the scaling decisions you might just decide to make are very different than the ones you thought you had to make right when you're right in the inception. And then finally, touch on this a little bit earlier, but the working groups are really important, right? Having that cross-functional working group, working with the same panel over a really long period of time, you understand how to work well together. You understand the leverage and impact others will bring, and you can really leverage that. So moving on to the next slide. Next, I want to chat about what was the long-term vision on Drive. So a lot of what I talked about was how we iteratively got from 0 to 1, 1 to 10, 10 to 100 by continuing to invest in the things that we knew worked. Partly keeping the lights on work, and partly growing partners and integrations and things that came in some ways naturally as next steps. Long-term investments can be very challenging for a business because there's no immediate payoff. A lot of times for Drive, for example, we own our own profits and losses based on the fact that we are the startup that I talked about earlier. Talking about something that might not pay off for 1 or 2 or 5 years as a volume play or a profitability play, it's a very tough investment to make. But by really thinking as a unit across all these sides of the business about what the long-term strategy is, and that dream big that I talked about earlier, how can we get to 50+% of DoorDash's overall volume? How can we be a partner that's doing delivery across all verticals, any types of deliveries, any spaces? It's important to spend some time with these investments earlier. So the way that we did that was to create, you can call it a ring fence, or you can call it a protected set of resources that are really gold and expected around investing in these areas, regardless of whether they might pan out or not, because not all your bets are going to pay out. You're going to take risks, you're going to make investments that you find out later either A, don't have product market fit, or B, there isn't a path towards profitability there. And you move on, you take the learnings from those things and you reinvest them in other places. So some of the early investments that we have worked on or are continuing to work on here are grocery, retail, and alcohol. And based on these investments we made over the past 4 or so years, you can see on the right some of the major partnerships and merchants that we now work with at scale that have been unlocked by this engineering, product, and operations effort that we've made. Yeah, the way that we did this, in addition to protecting the engineering resources, is by really relying heavily on our operations team. And operations coming in 2 forms, one being the business team that's kind of working with these partners, understanding their needs, as well as our product operations team that's really thinking about how we roll out our features, how we configure them, how we experiment quickly and get learnings, and oftentimes getting these learnings without engineering solves, so we can really know when and where to spend our engineering time. And thirdly, really thinking about thinking outside the box on what are other things we can do for growth rather than just the obvious. Delivery is our bread and butter here at DoorDash, but what are other services and opportunities we can provide to our users, our merchants in these cases, to help them grow their businesses and to give us an extra value add, an edge against maybe other folks that are just more traditionally thinking about delivery. So, we have some services here like support as a service, as well as some newer ones that we're thinking about to really give extra leverage to our merchants. One of the last couple of things I wanted to talk about is, now that we've achieved a high scale product, our engineering team has grown from the 4 or so engineers when I joined to the 80 or so person organization today. What are some of the challenges that might arise? So how do we continue to move quickly as a business and really think about platformization and ways that we can continue to be agile, as well as build really high quality products as reliability and scale become much more top of mind concerns and considerations for us. So I just wanted to highlight some of the things that folks are going to be chatting about over the next 30 minutes or so and give some context there. So reliability, Ryan Sokol, our VP of Engineering, loves to say it's our #1 feature. It's really important to us as a team. There's a number of approaches we've taken here around service extraction and service isolation, as well as bringing in technologies like circuit breakers and rate limiters. And, Jayanth is going to talk a little bit more about pragmatic engineering next. Secondly, building a platform for our API and our developers so we can really think about iterations, bringing extra value there and a level of consistency, which Patrick will touch on. Thirdly, understanding how we balance quickly iterating on products versus investing in major overhauls, especially on some of the deep technical challenges in our system, like our fulfillment platform, which Karthika will be able to touch on in a bit. And finally, this one's really important, is investing in process and tooling. As I said, the size of our engineering team has exponentiated, and building out automation as well as ways to help engineers move quickly becomes increasingly important. And I'd love to hear Ayushi's thoughts on that in a little bit. So last note here, we have a really successful playbook that we built on Drive. It's allowed us to grow this $1 billion+ business. And it was kind of our first one of the first times that we created a startup and created this unit around doing so and got some learnings there. So why stop there? We've really taken that success and built out a lot more of these incubations here at DoorDash to really repeat those learnings, understand what works, and put them into practice again. A couple of quick examples here. Storefront is a product we built to enable a web front end for merchants that want to power their own shopping experience. Dashmart is our in-app kind of DoorDash housed inventory or store where folks can order goods directly from DoorDash. DoorDash for Work is our enterprise product where we can sell delivery through the DoorDash directly to businesses that want to offer this to their employees. And finally, marketplace convenience and grocery is something that very much grew out of Drive, where the learnings that we took from grocery and retail and built out as a product market fit and profitable business on Drive, really we could take those learnings to actually start offering these things into our marketplace. And there's many more to come. So I hope you folks learned something about Drive today and how we got here. At this point, I'll kick it over to Jayanth to talk about pragmatic engineering. Thanks, folks.
Thanks, Jay. Hi, I'm Jayanth Visweswaran. I too am located in the San Francisco Bay Area, and I've been at DoorDash and Drive for the last 3 years. And for the last year, I've mostly been working on the Drive platform team, essentially helping build infrastructure that would allow the Drive team to scale even further. Okay, so During the first few months of the pandemic, due to shelter-in-place orders from across multiple geos, the growth of Drive far exceeded any projections that we had in place for the business. This meant that we needed to quickly figure out how to scale our infrastructure to support a very rapidly growing business. So DoorDash essentially builds iteratively, meaning the initial approach to building Drive was mostly as an experiment within DoorDash's existing monolithic service. And any reliability measures that were added in places where we were able to predict increased demand. The monolith in question was running Django on Python 2.7 and was quite memory inefficient. So so the number of requests handled per instance was quite low, and therefore we needed a large number of instances to be able to handle and support the volume of incoming traffic. The underlying infrastructure also, specifically in this case, data stores like Redis or Postgres, were also hitting the capacity on the number of connections they could hold, increasing the number of instances of the monolith to handle the incoming traffic, increase the number of connections to these data stores, and that sort of was reaching its capacity and was struggling to keep up. There were also the usual challenges of working within a monolith. While Drive was growing, so was the rest of the company, and having multiple teams working within the same code base was starting to get untenable. We wanted to approach solving this problem of scale in as pragmatic an approach as possible. The steps we took were to first observe, understand what needs to be fixed, isolate the traffic, let Drive traffic only touch Drive-specific code bases when possible, building data abstractions and give yourself the ability to change underlying data stores without affecting the business logic, and finally to extract out the core logic. First, observe. We built dashboards for everything. We were able to build dashboards with such great detail that we were able to correlate changes in any charts to changes within the system. And if anything breaks, we were able to quickly identify what broke and revert that change, or what change caused that breakage, and revert that change as quickly as possible. The one key thing to point out is we learned the hard way that there is a significant difference between when you need to use a log and when you need to use a counter, since there are different metric lags for each type of observability tool that you use. So therefore, you might take, if you're using logs, you might see a larger lag before when you see the result of an action you take. Isolate traffic. We observed that many Drive outages were the result of unrelated Drive code, was the result of bad deploys unrelated to Drive code paths. One of the first actions we took was to set up an isolated Drive pod that would allow Drive-only traffic within the monolith to touch and activate only Drive-specific code. This allowed for Drive to be protected from bad deploys from non-Drive teams and vice versa. On the next slide, we talk about abstraction. Another observation that we made was that we were seeing an increased volume of read and write pressure on our main database, and we needed to move Drive-specific data out of this database. So what we ended up doing was building data abstractions so that the business logic that relied on Drive-specific data would be unaware of any changes to the data store. And once we built these abstractions, we were able to move Drive data into its own database. The process of moving data was pretty straightforward, ensuring double writes to both databases, backfilling any missing data, and cutting over all traffic to just use one database. And finally, our end goal was always to move our code out into an independent service, something that is written in a more reliable and more modern language and framework, and at least something that would allow us to scale more efficiently. We did this using a BFF architecture. The BFF architecture, the backend for a front end, simply allowed us to inject logic up top that would dictate how we throttle traffic. We were able to shadow traffic to both services and verify the outputs to confirm, to validate correctness. And we were also able to throttle, to build throttle mechanisms that allowed us to cut over merchant by merchant, so that in case anything was broken with the extracted code path, it would affect a very small and predictable user base. Lastly, some closing thoughts. We worked hard to prioritize which APIs and code paths offer the best value and moved over to a service. Having that prioritization allowed us to make decisions that were able to give the business the best value for the investment they made in allowing us to extract this code out. And lastly, we always budgeted for failures, meaning failure is fine as long as we're able to recover very quickly. We used a system of feature flags and runtimes that would allow us to deploy code. When the code is deployed, it's inactive, and we have a feature flag that will quickly allow us to roll back when required, roll forward and roll back when required. And that's it for me. Next up is Karthika to talk about building a point-by-point delivery system.
Thanks, Jayanth. Hey everyone, my name is Karthika and I've been a software engineer at DoorDash for about 4 years. Because I was here for a while, I got to see why we made certain decisions and the need today to iterate on them. This talk focuses on how we are transforming our existing logistics engine to a version which will enable us to enter quickly into newer verticals. It starts off with the reason for this change, and then I'll dive into the new data models and architecture. After that, I'll cover a use case that we are implementing with a new version of fulfillment. Next slide. One of our values is dream big and start small. We wanted to be the winner in the last mile logistics space, but we started off with food delivery. All our data models were built to deliver from a store to a consumer. Delivery was like the smallest unit of work, and in order to create one, it had to be linked to a store and consumer. Now, with a dream big motto in mind, we wanted to pilot new initiatives. For example, peer-to-peer delivery. Simply put, peer-to-peer delivery is a dasher will pick up an item from a consumer's residence and deliver it to a receiver. Because of our data model delivery, which was constrained to have a store and consumer to it, we had to create fake stores to mimic a sender. Apart from the hassle of maintaining these fake stores, we had to write a lot of custom code to pilot this. There came a point in time when launches to new initiatives was taking a lot of time, and hence we decided to iterate over the existing fulfillment models. Next slide. In Fulfillment 2.0, we decided to break down delivery and came up with a smaller model called task. A task represents like the smallest unit of work. For example, pickup, drop off, these are all tasks. And a combination of tasks in a task group builds up to a workflow. For example, delivery can be broken down into 2 tasks, one which is pickup and drop off. With these smaller models, we were able to easily attach them together to build out a bigger workflow. In this case, moving furniture would consist of 2 tasks. One will be picking up the furniture and the other one will be dropping it off. Next slide. The diagram on the left actually shows the different services running today. On a high level, Drive creates delivery using the APIs provided by the delivery service. Parallelly, Dashers check in or start a dash using our Dasher service, and the request comes in through the Dasher mobile BFF. Apollo constantly transfers this data into Deep Red, which actually makes the assignments based on a number of constraints. One example would be certain deliveries can only be delivered by Dasher's own cars. Deep Red actually computes a list of the possible routes and scores them and picks the best one. These routes are then published to the assignment service, and Dasher app polls these polls from the assignment service, and the new updated routes are reflected there. Now, in the newer version, we'll actually be replacing the delivery service with the task service. So task service which will actually provide APIs for CRUD operations. We'll also spin up a new service called the DX Fulfillment Platform, which will encapsulate a lot of the common logic like pickup, drop off, or anything newer that comes in. So let's say we want to launch a new initiative. In this case, the new service that is going to build on the workflow will use the APIs provided by the task service to create tasks and all the actions provided by the DX Fulfillment Platform service to enable it. It's on a high level, it's more like a plug and play model. Next slide. So first and first down is something that we are implementing in the newer version with the Fulfillment 2.0 model. I'll basically describe the hacks that we had to do with the 1.0 model And then the ease with which we'll be able to roll it out with the 2.0 model. This was an initiative that we started in 2020, where we decided to make assignments when a Dasher reaches a store. For context today, assignments are actually made prior to Dasher reaching a store. And we believe that if we make an assignment when a Dasher reaches the store, we can increase the efficiency of a Dasher by reducing the Dasher wait time. So in order to pilot this, we wanted some form of bringing Dashers to the store, and we had to set up these fake stores and fake deliveries. I pasted the experience on how FIFO looked a while back. That is, a Dasher used to come on a fake delivery to the store. We used to unassign the Dasher from the fake delivery and then assign them to the real one. Obviously, the experience wasn't the best, but in the 2.0 model, we just have 3 tasks to achieve this. One is go to the store, one is pick up the order, and the other one is drop off. Next slide. This slide basically on a high level describes all the advantages that we're getting with this model. The biggest one being we can easily, because of this whole plug and play framework, we can easily launch newer initiatives and we don't have to do any more hacks anymore. Thank you. Then I'll hand it over to Patrick to describe our APIs, the new version of our APIs.
Hello, everyone. I am Ayushi Jain from Drive Merchant Experience team, and I'm also based out of the Seattle team. Today, I'm going to talk about our journey of how we went from manual way of handling localization for our front-end apps to a much more streamlined process. First, let's see why do we even care about localization in the next slide. Okay, so DoorDash has expanded to global economies, and localization is an important aspect for us for ensuring that each page makes sense in a linguistic and cultural context for each country. If you have your site set on global expansion, implementing localization into your business strategy will help you overcome cultural barriers and also facilitate entry into new markets. When the users can connect with your website and understand what you're trying to convey, it improves the user experience, brand loyalty, and CSAT. Down below, you will see 2 snippets of DoorDash.com. One is from France and one is from Germany, 2 of the marketplaces that we are in. Let's move on to the next slide. So how are we doing localization for our front end before this automation process was established? Here, I'm showing you snippets of Figma, and on the right side, our code. DoorDash strives to build consistent, responsive, and accessible designs across our products. And our design team uses Figma that go through several rounds of product approval processes. On the left is a Figma mock of one of the front ends that we have built. And on the right, you can see that for translation, for picking it up for translations, we have to manually copy paste every single string from our mocks and build out the JSON file that our translation management systems can interpret. This is a manual process, as you can see today. For automating the whole process, the engineering and design worked very closely. As we can, let's move on to the next slide. So as we can see here, this slide explains the design team's workflow in this automation process. This was a total one team, one fight effort where engineering and design collaborated on building the framework. At DoorDash, we have common component libraries that enhance reusability and consistency across our user experiences. The first thing that comes up in the design team is when they're building their mockups, they have full understanding of what product they're trying to build, and they are able to annotate mockups with semantic metadata. As you can see in the Figma annotation screenshot, there is a label called text plus data, and I'll talk about why that is important. The second thing is when you are using these component libraries, you have to identify all of the translatable attributes. For example, you're using a button in your website, you need to localize the button title or the button label so that it can adapt to different countries' user base. The third thing is identifying interpolation and strings. What do we mean by interpolation? Sometimes you have data coming from API responses that you do not localize, but it plugs into translatable strings. While our design team is annotating these mocks, they have this awareness and they bake it in the Figma mocks by means of all different annotations that you will see in the curated list. Now, let's move on to the next slide so we can see the engineering team's workflow. Once the design team hands over the mockups to the engineering team, we start the process of productionalizing them. So for the engineering team, the curated list of keywords that we have identified with the design team, they help us build tooling around that. What we do in the end-to-end process is we take the Figma mockups, we export all of the frames that Figma has a default frames in the mockups. We export it into a CSV. We develop tooling around that CSV so that we can parse those curated lists from the CSV and build a JSON that the internationalization library can interpret. We are using I-18 Next for internationalization and SmartLink as a translation management system. We also incorporated some niceties in our tooling where we could build contextual string keys for the JSON and accounted for interpolation and duplicate detection. You can also bake in some other niceties in your framework to filter out keywords while building contextual string keys for JSON. Next slide, please. Here we'll see how end-to-end this whole automation process works from design to engineering. On the left side, you'll see that we have Figma mockups. I'm using a community plugin here called copy.textkit, which is used to export all of the Figma text layers into a CSV file. On the right side, I'm showing the CSV that it will download. I've already downloaded it here. And in the CSV, you will see the column 3 is the list of all the curated keywords that the design and engineering settled on for annotations. And our tooling will pick up these from the CSV. And on the column 4, you will see there are all the strings that actually need to be translated. If there is a string that has not been annotated with the curated data set, we will skip that in the translations. I'm now running this script to automate. And here we have built a 150-line JSON in just a minute. Earlier, this was all done manually by copying strings manually from Figma mockups to the JSON files. So next up, let's look at the advantages of automation. The advantage is the direct win here. It was improving efficiency and engineering velocity. It's also aligned with our core engineering value of getting one person better every day. So when you are licensed, if you have an in-house translation system, good. But if you are licensing to a third-party system, you're definitely using some kind of pay model to pay them for the translations. By automating this process, we are reducing the number of iterations of translation requests that we are sending to the third-party systems. And we are also ensuring 100% coverage. And every time you submit a request for translation, there is a wait time when the translation team is getting back to you with the updated localized files. You're also enabling cost savings because the number of requests that are going are much fewer compared to before. And last but not the least, we have also improved efficiency by automating the creation of localization JSON files. So engineers don't have to focus on moving strings anymore, and their time frees up. So I hope you're able to leverage some of this knowledge in building your own localization automation framework. That's all I have for today. Thank you. And next up is Q&A, and I'll hand it over to David.
Okay, so we've got a number of questions in the Zoom Q&A. The team is going through and answering some of those, so they've answered those over text. I think what we'll do is we'll walk through the remaining questions and do our best to answer them live. But hosts, feel free to continue to type in answers to some of the questions if you have them as well. So I'll actually start with an answer to the first question at the top of the list here. So VJ asks, with regards to companies and sectors where DoorDash was not able to win their business, other than cost, what other factors made the customers not choose DoorDash? And what has DoorDash done to allure those customers in the future? So, VJ, as you noted, cost is, of course, one of the reasons why someone may ultimately choose to go with a different option. But if we take cost and put it aside, Jay was mentioning at the beginning of the conversation that in the early days of Drive, we really focused on larger enterprise customers where, to some extent, the juice is worth the squeeze, right? We can have a bespoke approach to integrating with them because we're going to get, a significant amount of volume in exchange for that kind of high touch white glove integration. If you look at the long tail of other customers, though, that isn't always the case, although with the work that Patrick talked about, we're now aiming to achieve that. And so certainly in the earlier days, for the long tail of, let's call it mid-market or maybe mom and pop shop type customers, we often didn't have the capabilities to support their needs. Those capabilities could have been things like just enabling them to onboard automatically, or it could have been bespoke needs that they had that didn't make sense for us to build more generally because they didn't apply to a large enough sort of population of the customers that we serve. So when cost isn't the reason, usually it's capabilities. Over time, of course, as we've now been at this for 5+ years, we've been able to iterate and build a bunch of these capabilities into the system that didn't exist, say, a year ago, 2 years ago, 3 years ago. And so oftentimes when we go back to the table to have a conversation with customers, it's on the back of these new capabilities existing where they may not have in the past. And now to some extent, we're repeating that process with the V2 version of the API that Patrick mentioned, where the initial version really focuses on self-serve, but doesn't have maybe the breadth of all of the capabilities that we've built up over time in our V1 APIs. And so we're kind of going through this iterative process again, adding the most important capabilities to go win those contracts from, from the broadest set of customers. Okay, so that covers that one. Let me jump to the next question here. Jayanth, I think you're in the middle of typing an answer, but maybe you can just answer live. So this question is, how do you ensure that your tech stack isn't constantly changing and you aren't increasingly accumulating tech debt as you modify business requirements from your learnings?
So one of the things we do to ensure that we don't change up our tech stack constantly is standardization. Over the last few years, we've experimented with multiple frameworks and multiple languages, and across DoorDash, we have certain standards as to what we want to build and how we want to build. For example, interprocess communication is going to be fixed with gRPC for as long as it works. The language of choice for DoorDash is Kotlin, as long as that works for our needs. So having standards across the board, across DoorDash, really helps solve that problem. In terms of trying not to accumulate tech debt, one of the investments that the Drive team has made in the last year is to sort of build up a Drive platform team. And this Drive platform team sort of helps product engineers building product-specific features make trade-offs so that they can achieve the goal as fast as possible, and at the same time, try not to accumulate too much tech debt. And if there is tech debt that is accumulated, in some cases it is worth the cost, and in other cases, the platform team will help sort of figure out ways to not necessarily accumulate that debt.
Awesome, thanks, John. Okay, we have several questions on kind of V1 and V2 API. So Patrick, I'll read one or two of them, and then maybe you can just provide kind of a general overview. All right, so the first is from Keith. I'm curious as to how you were able to stick with your V1 API for 4 years without having to version. What techniques did you use to build upon that V1 and add new capabilities without introducing breaking changes? Specific examples would be great. And then there was also a question further down the list here regarding the API cutover to the new version. Can you describe how you plan to retire the old version of the API? So maybe you can take those as a pair, Patrick.
Sounds good. About how we were able to maintain this API for so long. I think first, it really started with having clear design principles that are well documented and followed, and holding a high bar for API design. Making sure that everything from naming to structure, all of those are consistent, and that as new changes come in, they abide by those rules. It has allowed us to keep that API backwards compatible and forward-looking as much as possible. With that said, as I mentioned in my talk earlier, there's a number of things that we realized down the road, and they're impossible to see, and we're finally starting to version. We've saved up some of the pain and things we weren't able to fix with backwards compatible changes for the second iteration of our API. You asked for specific examples. One of them was how we think of estimations. Often our V1 API thinks of you get an estimate, and then you go and create a delivery. But the estimate you get for both time and price aren't guaranteed by the time you create it. So actually it can change between. In our new model, we've changed to a quote and accept model where you get an actual guaranteed quote and you can accept that. Another thing that we changed from our V1 to our V2 is originally when we created this logistics platform, we really thought in terms of stores to customers, from businesses to customers. But as you heard throughout the talks, a lot of our logistics scenarios have gotten a lot more complex. And we are designing for those new scenarios with the V2 API. The second question, David, do you mind reminding me what that was, please?
Yeah, just how we're thinking about sort of deprecating V1 as we move to V2.
It's a very good question, and one that comes up internally in a lot of conversations. Simply put, we've got some very, very large merchants that are using our V1 API, and we cannot turn them off, and we can't afford to do it. We are going to keep backwards compatibility for that V1 API and make sure it uses as much of the new code paths as possible to reduce the maintenance costs that we have there, but we plan to support that V1 API for the foreseeable future. So we do not plan to turn off that API.
All right, I think we have time for a couple of more. Let's take this one. Sounds like you've had a ton of learnings, which is awesome. What are your main pain points now, and what are you focused on prioritizing for the next 12 to 18 months? So maybe I'll take this. I think as with most businesses that scale rapidly, the challenges that we have today are much more on the order of how the business continues to scale and grow responsibly. And that tends to decompose into a couple of themes, right? So the first is stuff like reliability. It was much easier for us to solve for reliability when we were 1/100th of the size we are now. And that's everything from ensuring that we have maturity in our observability stack to maturity in things like fault tolerance. And we talked about this extraction from the monolith. A lot of what motivated that was a lack of fault tolerance at scale, where an adjacent issue with a different part of the business was taking us down when it didn't need to, as a concrete example. And so, a lot of our focus right now is really on sort of that reliability and building for the next 10x or 100x of scale. The other main sort of scale challenge we have goes back to my comment about capabilities. As we are going beyond just serving restaurants and into verticals like retail, and as we broaden the use cases through the V2 effort, there are a bunch of capabilities that exist for new kind of end-to-end use cases, whether it be in grocery or pharmaceuticals or deliveries that maybe aren't 20-minute ASAP deliveries, but are deliveries that can get serviced over the course of a day. And we have a lot of ideas about how we can go solve for all of these things, but there are a bunch of sort of things pulling at our resourcing in parallel in terms of what we go after first. And so most of the challenges we have right now in terms of pain points are that balancing act of protecting the core while expanding capabilities and doing all of it while maintaining and improving reliability so it can continue to be our #1 feature. All right, I think we're just about at time. There are a bunch of additional questions here. We did our best to get through a good bulk of them. I think we answered about 20, and there's still about 15 or so left. So apologies for that. If you are interested in engaging further on this topic and want to chat more, feel free to reach out to me directly. My email is da@doordash.com. Happy to connect you with folks on the team to learn more. Happy to talk to you about opportunities, on DoorDash Drive or at DoorDash more generally. And again, thank you everyone for joining us. Hopefully this was valuable and insightful. And we look forward to seeing you at future tech meetups. Okay, thanks again.